to the lesson on sketches and cross sections. In this lesson, we will take a look at two-dimensional and three-dimensional shapes, how to sketch them, and some manipulations of them. Drawing figures in geometry can be a tough task. As I'm illustrating here, my intention is to draw a hexagon, and I would do so by drawing 3, 4, 5 lines, and then you see just through a simple miscalculation of distances, my sixth side appears to be strange. My goal was to try to draw one and have all the sides be equal to each other. But there are some steps to help us better draw out even complex shapes. The first step would be start with a circle, which can easily be made with a compass. Then on that circle, we would plot 6 points and make sure that those points are evenly spaced. We can discuss how to do this later. By then connecting those 6 evenly spaced points, we will achieve a perfect regular hexagon. Now, to ensure those points are evenly spaced, we know that with a circle we start with a center, and that center can connect to all those points with equal radii, and those radii make an angle of 60. Between all of those points, there will be 60 degrees. Let's try the same thing with another circle, and this time around, let's make a square. So from the center of the circle, I'll draw a radii. I'll draw a second radii, and making sure that my radii have an angle of 90 degrees. So I can extend each radii and turn it into a diameter, and then connect the 4 resulting points into a perfect square with all angles 90 degrees and all sides equal. Continuing on with 3D shapes, we will have some basic principles with some easy steps and easy rules to ensure that we draw perfectly, although it may not always come out perfect every time. So let's start off with a hexagon, then we want to turn it into a hexagonal prism. We'll want to start by drawing 6 line segments of equal distance, equal length, and make sure that they're all headed away from all 6 points at the same angle. You can then connect the ends of those points. And as you see here, one of mine might have been a little bit too long. And by connecting them, we should see that we've made another congruent hexagon in the back. Now, because we are looking at a two-dimensional representation of a 3D shape, it's understood that not every single line is visible to us from one particular angle. So as I erase some of these segments, I see that these are dotted because they are not currently in my view. From the view of this hexagonal prism, I'm not able to see those sides, I'm not able to see those edges, so the dotted line creates an understanding that that's not what we're able to see. Now looking at a pyramid. With a pyramid, I draw the apex at the very top away from all the points of my polygon base, and I draw a line segment from that apex to every single point of my polygon base. As all the line segments connect at the apex, I have a pyramid with the 5 sides, in this case a pentagonal pyramid. As we move on to cross sections, we literally think about taking a slice out of a 3D prism. So taking a look at my cylinder, if this plane, rectangular plane, cuts through my cylinder, what shape is created? What does my cross section look like? As I indicated here with the dots and then the solid pink line, my cross section will be a circle, namely because the cross section matches the base because it is parallel to the base. On the other hand, if my cross section appears to be vertical to my bases, the cross section will match the lateral shape. In this case, it'll match a rectangle. When thinking about cross sections, it might be good to think about slicing a log of cheese or even a loaf of bread and how every slice is identical to the shape of that loaf. But let's do a few practice problems, including some of the practice problems from your own information, from your own packet. So we want to describe the cross section of the intersection of this hexagonal prism and a plane parallel to its base. Because the plane is parallel to its base, the cross section of that intersection will end up being a hexagon as well. The base of the prism is a hexagon, so the cross section is a hexagon. This time around, the plane is not parallel to the base, and instead it's perpendicular, so the cross section would end up also being a rectangle. Let's take a look at one more example, and let's talk about drawing a perfect pentagon. So again, we'll start from a circle. We'll put a point in the middle of that circle so that we can start. And I can think a pentagon has 5 sides, so I want to evenly space out my points 72 degrees because I'll take the 360 degrees in a circle and divide by 5. So I will do this for every single one of my points. 5 points in total because the pentagon has 5 vertices. And after connecting those points, we'll see that I have very close to what will be a perfect pentagon. Of course, with the proper instruments, it'll come out perfect.